Okay, so standard enthalpy change formation is given delta HF. What also, because it's standard, what other symbol are we going to put here? Yeah, little underground sign, like so. There we go. Is the enthalpy change when 1 mole of a compound is formed from its elements in their standard states under standard conditions. What are standard conditions? Standard conditions, temperature is going to be 298 Kelvin. What about pressure? 100 kilopascals. And if I have to use solutions, what solutions would I use concentration-wise? 1 mole per decimeter cubed. Like so. So it's always a good idea to quote the standard conditions as well. So shall we do an example of a standard? So let's do the equation for methane. So e.g. for CH4, which is methane. I've got to make 1 mole of methane. What is the standard state of methane? Is it a solid, a liquid, or a gas? Gas, yeah. That's right. From its elements, what elements make up methane? Carbon and hydrogen. How do I write, oh, I don't know. I write hydrogen as H2. It's automatically done. What state is hydrogen in? Gas. What state will carbon be? Solid. And how do I get that to balance? I need a 2 there. So that would be the equation for the standard enthalpy change of formation for methane. Right, let's go through the ones that we've got so far. So we need to do the enthalpy change of formation. Now the way I would go about this is I would always put your product, write your product first. So I've got to get to water as a liquid. Get that sorted. Remember, you can only ever form 1 mole of this for formation equations. Let's now look at my elements. I'm going to stick there. I've got H2, which is a gas, and I've got O2, which is a gas. How can I get that to balance? The only way, I'm not allowed to change that, is to put a half there. Okay, so I'll go to you now. I've got ammonia in the gas. What do I need to put here? N2, yeah. Plus H2 gas. And how can I get it to balance? Yeah. Yeah, cool. Like so. Ethanol. C2H5OH. Of course, a liquid. Now, I've got 3 elements here. So I need to put in carbon as a solid, hydrogen as a gas, and oxygen as a gas. Balancing wise, I need a 2 there. How about hydrogen? 3 there, and oxygen? A half there. Cool. Bromomethane. Again, put in your bromomethane so you know where you're going. Again, 3 elements, so I've got carbon plus hydrogen. Remember, bromine, of course, you write as a diatomic liquid. Carbon sorted, that's a solid. Hydrogen is going to be now, yeah, and bromine, a half, brilliant. And finally, sodium oxide, got to get to Na2O, solid. I'm going to have sodium here, solid, plus oxygen, O2 gas. I need a 2 there and a half there to get it to balance. When you're doing standard enthalpy change formation, you need to remember only form 1 mole of compound. That's where people make loads of mistakes. And also, what will be the standard enthalpy change formation for an element? It's going to be, so if I said, what's the equation for the standard enthalpy change formation of N2 gas? The equation would be N2 gas going to N2 gas. So what must be the value of that? 0. Nothing, is it? Yeah. So for 4 elements, it's meaningless. For elements, delta HF equals 0. So just because they try and catch you out on that one in the exam. So remember, for elements, delta HF is always going to be 0.